The global surge in AI adoption has been a central driver of Nvidia's explosive growth. As organizations race to implement AI solutions, Nvidia's chips have emerged as the backbone of this technological evolution, catapulting it to the top as the most valuable company in the world. But now things are shifting, and the company's about to face some serious competition. Is this the end of Nvidia's monopoly? Stick around to the end to find out. Nvidia holds approximately 80% of the AI GPU market share, and from the surface, anyone can fall into this belief that it's only the hardware that sets Nvidia apart. But in reality, it's the software, the whole ecosystem that serves as the most impenetrable fortress around Nvidia's AI infrastructure. If you're even remotely involved in AI, you've probably noticed that almost all deep learning happens on Nvidia's GPUs, whether for training or inference. According to a report by Stanford Human-Centered AI Group, GPU performance has increased roughly 7,000 times since 2003, while the price per performance has improved by about 5,600 times. In terms of inference alone, Nvidia's GPUs have reportedly achieved a 1,000-time increase over the last 10 years. Yes, Apple currently has managed to retain its spot as the most valuable company in the world, but Nvidia is there at second place, and the margins are not too high. All of this is not just because they make incredible GPUs. Nvidia's real strength lies in something more strategic: their AI software USP. So what exactly is software USP? Originally, GPUs were built just for graphics processing, and they had a fixed function pipeline that couldn't be altered by users. But then came shader programming, with languages like GLSL and OpenGL and HLSL for DirectX, which allowed users to program parts of the GPU pipeline. This made GPUs a lot more flexible. While other companies pushed for the OpenCL open standard, Nvidia launched CUDA, a proprietary closed-source solution. From that point on, Nvidia didn't just lead the gaming GPU market, they leveraged that success and stayed ahead. So why has CUDA been so powerful? Well, it's all about the design. CUDA gives developers deep control over the GPU's low-level operations, especially its memory and computation structure. If memory is accessed inefficiently, the system slows down. CUDA exposes these memory levels so developers can target the best memory for the task. Unlike GPUs, which work with simple threads, CUDA uses grids, blocks, and threads because GPUs have a more complex execution environment. OpenCL, designed for both GPUs and CPUs, hides many GPU-specific details, making it harder to tap into the GPU's full power. But with CUDA, developers have the access to the core working of their GPUs. Data scientists around the world are using it right now to train the most powerful machine learning models. Here's how it works. You write a function called a CUDA kernel that runs on the GPU. Then you copy some data from the main RAM to the GPU memory. The CPU tells the GPU to execute the function in parallel. The code runs in a block, which organizes threads into a multi-dimensional grid. When the GPU is done, it copies the results back to the main memory. Simple, right? Now, let's talk about PTX, the machine code that CUDA generates. Nvidia isn't afraid of change. In fact, they've rolled out over 12 versions of PTX. This flexibility lets them innovate quickly without being held back by backward compatibility. It's kind of like how Android or ARM assembly evolves, giving developers room to adapt without being stuck with old versions. CUDA is great for development, but it also creates a vendor lock-in. Every time a new version of CUDA drops, developers need to recompile their code. CUDA's dominance has led to a natural ecosystem where frameworks like PyTorch target it directly, ensuring that nearly the entire machine learning community uses NVIDIA GPUs. CUDA's closed-source nature means that if someone tries to replicate it, they'd face a massive challenge. If a competitor wanted to catch up, they'd have to replicate not just all the features, but the flaws too. PyTorch, originally developed by Meta, was built with CUDA at its core, locking users into NVIDIA's ecosystem. And once you've got a cluster built on NVIDIA's GPUs, you'll likely stick with NVIDIA for the next one too. With their GPUs, software stack, and deep integration into machine learning frameworks, NVIDIA doesn't just dominate the market, they've made it nearly impossible for competitors to catch up. But as I mentioned earlier, things are now changing rapidly, and if NVIDIA makes a navigation error, the company might see a freefall. The AI hardware market is rapidly heating up as companies like AMD, Intel, and rising contenders like China's More Threads challenge NVIDIA's long-standing dominance. AMD is making strides by offering better performance per dollar, especially in the low-end market. While its ROCm platform and the acquisition of Nod.ai, AMD is positioning itself to compete head-to-head with CUDA. Intel, not wanting to be left out, has jumped into the GPU market with its Arc devices and One API initiative, aiming to create a unified platform for machine learning tasks across both CPUs and GPUs. However, Intel has encountered hurdles with CUDA alternatives like ZCA, tangled in legal challenges from Nvidia. Nvidia is also increasingly focused on high-margin data center products, shifting its strategy upward. But as this plays out, the traditional market forces that have shaped the computing industry for the last 50 years are bound to kick in. As Nvidia targets the high-end markets, consumers will start pushing back, seeking cheaper and more accessible GPUs and finding ways to make them work. Right now, many argue that retail GPUs fall short due to RAM limitations, but that's bound to change. Software will adapt, running efficiently on consumer-grade GPUs, whether through open-source projects or new AMD or Intel solutions. This isn't new in the world of computing. Low-end innovation has always been a thorn in the side of giants like IBM and now Nvidia. While Nvidia has a chance to maintain dominance in the long run, monopolies often overstep and become their own downfall. Nvidia is reaping massive profits, but in doing so, it's creating a scenario where customers will eventually look for alternatives, boosting the competition that Nvidia tried to block. For Intel and AMD to take down Nvidia, they can't play Nvidia's high-end game. Instead, they need to focus on producing the most cost-effective, powerful GPUs they can. They should also exploit Nvidia's artificial limitations, often enforced through drivers that push consumers toward more expensive, data center-oriented GPUs. Where Nvidia locks things down, Intel and AMD should be all about freedom. Where Nvidia is closed source, Intel and AMD should champion open source solutions. Following that, Nvidia may not lose its dominance right away, but its monopoly will eventually falter. The competition will rise from Nvidia's consumer-unfriendly stance. In the world of computing, consumers are clever. They'll always find a way. Alternative software stacks are emerging to sidestep CUDA altogether. Spectral Compute, a UK-based startup, has developed a cleanroom re-implementation of CUDA with its Scale platform, specifically targeting AMD GPUs. Similarly, OpenAI's Triton is allowing developers to write high-performance GPU code for NVIDIA hardware without relying on CUDA. PyTorch 2.0 is also expanding its backend compatibility to support AMD and Intel GPUs, challenging the grip that CUDA has always had on the AI ecosystem. What's needed now are programmers who can unlock the potential of affordable GPUs like the AMD 7900 XTX with 24 gigs of RAM to run cutting-edge AI effectively. Threats of NVIDIA's monopoly aren't just strategic but also political. In response to the US ban on high-performance NVIDIA GPUs, Moorthreads, a Chinese company, is making waves in the local market with its Musa architecture and Musfi tool. While it's not as fast as NVIDIA's top offerings, they're carving out a space in a region where NVIDIA's presence is limited. While NVIDIA continues to lead with GPUs that remain top tier for many AI tasks, these new competitors are a formidable threat. Open source initiatives, competitive pricing, and alternative compilers could erode NVIDIA's market share over time. Although replicating CUDA's functionality and navigating the legal complexities are no small feats, these alternatives are putting pressure on NVIDIA's pricing and ecosystem control. In the end, while NVIDIA is still innovating, the rise of alternatives signals a future where the AI hardware market could become much more competitive. This shift could lead to better performance, lower costs, and more innovation, ultimately benefiting developers and organizations alike. I have made another video showing some light on the darker side of AI. It actually tried to deceive and scheme. How? Click on the video link popping up to find out.